Hello everyone, and welcome to another video from the Canal Sidings Model Railway channel. This one is again featuring my North Grove TMD layout, and in particular the progress on my single road loco shed and the surrounding area. I have now completed all of the track laying in this area, apart from connecting this track here, which is the entrance track from the TMD, sorry, from the loco shed up to the point which is further down. That is one of my next jobs to do. I have also got a little bit more hard standing to add inside the shed at either end of the inspection pit, which is also part of my next task. But other than that, the concrete hard standing, which is all this white stuff that you can see, is now in place and simply needs its concrete surface putting on. And again, that is one of the next jobs to do. The building is now fully lit and also features the ability to pick it up and move it, and put it back in exactly the same place, and that registration and the connections to the internal lighting are all done by exactly the same two pegs. But first of all, I'll show you the building lit by turning out the room lights and turn on the building lights, and then I'll demonstrate how we remove the building, and then we'll go over to the workbench where I can get down a bit lower, and we'll look at the building upside down to show you exactly how the lighting is in there, has been added, and how the electrical connections get to it. So the first thing I'll do is I will turn off the room lights. It's not completely dark because this is Monday afternoon at just after 3 o'clock, so the room isn't completely dark, but the view on the camera shows it as pretty much completely dark. And what I'll do is I'll turn the building lights on. It's just a case of connecting two wires together at the moment. There we go. That is all the building lights on. That doesn't include the inspection pit lights, because the wires to them are not accessible to me at the moment. So the inspection pit lights are out. They are the building lights that you can see. And those building lights, as you can see, consist of a set of lights inside the building, which are all up at about this level, if you can see that, just about the eaves level, and also 3 outside lights, those and that one, which are for personnel to walk along the side of the tracks and to get at the equipment that controls unloading of tank wagons that really should be on that siding. The box van that's up there, the VDA, wouldn't normally be on that siding, but of course could be, because it could be unloading spares and stuff like that. So there you have the building lights. There will of course be other lights in the area. The refueling point, which is here, is going to have a light up under there, which I haven't fitted yet. That refueling point isn't fixed, it does come down, does come out. And there will be some yard lights as well. There'll be a yard light almost central in that picture, my guess is, and that might be a single yard light, and there will be double yard lights probably at either end of this picture that you can see, just out of shot. They will light up the area in front of and around the refueling point, sorry, the storage tanks, and they will also light up the yard for people walking up and down between locomotives and anything else that might be necessary. So what I'll do now is I'll turn the building lights, I'll turn the building lights off, and I will turn the room lights back on, and I will show you how the shed can be removed. Okay, right, just going through here, you'll see my head in the way in a minute. Okay, I'm just going to take the lock rannoch off, get it out of the way, and the VDA van out of the way. Okay, now the way that we remove the building is simple, except that I've just caught my hand on there. It's simple, and that is we just lift these two ends. And if I had left the building lights on, which I'll reconnect now that I'm the other side of the wire, building lights are now back on. As I lift this, building lights go out, and here we are, completely free. No wires connecting it at all, and I can take the building away. And I'm just going to put it down on the bench. The way that is done, I hope you can see, let's pick up the pointer again. I hope that this picture shows just there, and another one just there, are two pieces of brass tube. Those two pieces of brass tube are, and I'm sorry this is imperial because that's how they're sold, 5/16 of an inch in outside diameter, with an inside diameter of 1/8 of an inch. And on the bottom of the shed building there are two pegs that line up exactly with those two, there and there, which are 1/8 inch diameter, and that is what makes the electrical connection, nothing else. And then all the lights in the shed, apart from the ones in the inspection pit, which of course hasn't moved, it's still sitting there, but all the lights in the shed are connected to those two pegs, and the three exterior lights that you could see as well. This here is simply a guide. It's also a control box for pumps, whatever, for oil. But what I do is I simply bring this back, put the building so that it hooks in behind that, find that end one, and then if I'm lucky and can do it, the other end drops straight in. I'm at a funny angle to it. I normally try to do it straight onto the building, and now you can see the lights have come back on. All the lights are on, all the external lights, the interior lights. So what I'll do next is I'll take you to the workbench, such as it is. It's a bit of a mess at the moment. We'll tip the building upside down and you can see how it's wired up inside, how all the lights are connected. So I'll be back soon. Okay, here we are again with the shed on the bench, upside down. The shed, that is, not the bench. And you can see all of the lighting. First of all, here is the positive terminal for 12 volts, and here, which is just out of shot perhaps, is the negative terminal for 12 volts. And they run inside here to this one to a black wire, and this one to a red wire. This one's longer than that one because I ran out of the 1/8 inch material. I've now bought some more for the other shed. And the lighting is made up of these lighting strips, LED strips. There are two of them, as you can see, which I'm sure most of you will be familiar with, but for the ones that aren't, they are simply a set of LEDs which come on a reel. Can't even find it. Here we are. A reel like this, and they are just flexible. and you have if I can hold it, you have LEDs and resistors. So there's a resistor, an LED, an LED, an LED, and a resistor and LED. And basically you have 3 LEDs to each resistor. So if you connect 12 volts across these two, and there are lots of those places along here that you can do it, there are 2 more just there, 12 volts there, that provides a circuit through that resistor and 3 LEDs, and that produces light, as LEDs would. They're mostly used for mood lighting and party lighting, or lighting where it's difficult. I know quite a lot of people use them in dark areas of their railway, like field yards, etc., so that they can actually see what's going on. I know Graham at Lakeside has used them in his field yard, which is underneath the Lakeside layout, and many other people do as well. But I'm using them here as lighting for the shed. Now I thought about how a shed would be lit, where the lights would be. The obvious thing is to just put a row of lights down the middle here. But that doesn't really work very well, simply because all you're doing is lighting the top of the locomotive that's sitting in the shed. Anyway, I went online and looked for pictures of how shed lights are arranged, and to be honest, it's not that easy to find them. But I did find a couple of pictures, and usually they were arranged such that they were either side of the central track, and in a 3-road shed, in a 2-road shed, there would be 3 rows of lights, so that there was one either side of every track, the centre one being on one side of both tracks. So I decided that was what I would do, and I wanted the light even all the way along, and I didn't want to keep cutting these things about. So what I did was I used 21 LEDs. There's 3, 6, 9, 12, 15, 18, 21, yeah. 21 LEDs is what fitted the length naturally. Now normally those LEDs run at quite a lot of current and are very bright. Now I don't want them very bright. I want them to run at a sensibly low amount of current to be bright enough to light the shed, but I don't want them to be overly bright. So what that means is I need to add another resistor outside of all of that, outside of those LEDs and those resistors. And one more resistor can control the whole lighting effect. What I've actually arranged and found is best is to run each one of these strips at a total current of about 10 milliamps. That's less than half a milliamp per LED, and that was what you saw when I turned the lights on. So I have 2 strips, so the total current for the 2 strips is 20 milliamps. And it turns out that from 12 volts I need a 1K5 resistor, and that 1K5 resistor is here, and it goes from a 12 volt positive bus bar that I've stuck in the roof here to the 12 volts on that strip, and the 0 volts, and then that 12 volts on that strip is connected at this end, across to the 12 volts on the other strip, and the 0 volts for the 2 strips are connected at this end, and then the 0 volt power goes in at this end from here, and the 12 volt power goes in at this end from here. Sounds a bit complicated, but effectively it puts the 2 strips in parallel with one another through a common single 1.5k resistor. I could have used probably a 3k resistor to each strip and not made the wiring sound so complicated, but it works. The strips are actually fixed onto pieces of this stuff, which is evergreen strip 60 thou by 250 thou. They're not quite wide enough for the strip, but they do the job. And that is stuck at each position here using a bit of Yoo-hoo glue. That's this stuff. You've seen me use that before. That is stuck to these cross pieces, which are actually pieces of PCB material. They're fiberglass PCB material. The reason I use those is because they're far less flexible than styrene strip. Those are about 1.6 millimeters thick, not wide but thick, and they don't bend at all. Even on the 2-road shed they won't bend, and I just happen to have quite a lot of them, so I use them. But styrene would do just as well. You'd have to make it thicker, simple as that, so it didn't tend to sag under the weight. These bus bars are simply tinned copper wire. They're about 24 gauge tinned copper wire, and they are just glued onto each one of these with hot melt glue, and each one is glued to each one of them. Now that's not a complete success, because when you solder close by, the heat melts the glue again, because hot melt glue will just remelt, but luckily it re-sticks, so as long as you hold the wire in place it will cool and stick back again. So it seems to work. A bit of a messy job to do. The other thing then we've got is the outside, which I think you can see. These, yes you can. These 3 lights are something that I bought off of eBay. This one I've damaged by messing about with it, trying to see if I can bend it, but that's what they look like. Let me just put my hand underneath that so that you get a better idea what it looks like, without getting my hand in the light too badly. That's what the LED, what the lamp looks like. It's got a tiny LED inside, a little shade. This is bendable. You can actually bend that, as you can see. I've changed the shape. And then it's got a washer here on it, which goes through the wall. Just drill one hole in the wall and push that through, and you can see here, here and up here possibly where they come through the wall. And they've just got 2 wires. They come with resistors on, but I can't get, there's a fatal flaw in the design because you can't get the resistor through the hole, so you have to make the hole big and then the lamp flaps around. So I decided to cut the resistors off and go my own way. But the 1K resistors that they're supplied with are actually perfectly adequate for 12 volts and give a decent light. So what I've got is each one of these has got a black wire which goes directly over, in this one case, to here, and a red wire which in this case, if I could see it, goes out that way to a 1K resistor which is connected to the 12 volt bus bar wire, and they're all done like that. So that resistor is for that lamp and that resistor is for that lamp. Now what worried me was this all looks a bit of a mess. My wife looked at it and said, "Oh, that's tidy, very good," but you know, it's one of those things. Beauty is in the eye of the beholder, as they say. However, you can't see it once, and you obviously didn't see it when I showed you the building lit up, because it is actually all right up high into the eaves, as I said, apart from this little bit of wire here from these which are below the eaves level. And it's also all on the wall. Those are on the wall that you're looking at, so you don't tend to be able to see that at all. Plus the fact, by the time I've added some more details inside here, which you can see, like tool chests and lockers and fire points and battery chargers and lifting jacks, and all the other paraphernalia that seems to be in and around sheds, then I think there will be no you just won't be looking to see what it looks like. And if I now pick up my red wire, if I can find it, there we go, and my black wire, which actually is green, and I touch them to the black and the red, touch that one to there, and that one to there, the lights come on. You'll probably see that better if I turn the bench light off. Touch there, and the lights come on. And you can see that each one of those lights is not very bright, but together they produce a very nice light that's very even throughout the shed. So essentially that's it. That's how I have solved the lighting problem in my shed, such that I can take the shed building off and put it back in the same place, and at the same time reconnect the lighting. The hardest part of the job is getting these two spigots to accurately line up with the holes in the baseboard where the two other pieces of tube are that they drop into. And they sit in about 8mm, so there's a lot of opportunity for good electrical contact there. And the total amount of current that it takes is about 40 odd milliamps. So we're not talking minuscule amounts of current. We're talking about enough current to what am I trying to say? To tolerate a little bit of difficulty making connection. There's no difficulty there at all. I was quite worried about it when I first thought about it, and I tried all sorts of measurements with an ohm meter to see how two pieces of filthy old brass, I just picked up two bits of brass that were in my in one of my metal storage boxes, and just connected my ohm meter to the ends of them on the lowest range and pushed one into the other, and I was absolutely amazed at how low the resistance was. In fact, it was almost unmeasurable, the resistance at that point. And moving them about really didn't make a lot of difference. To be sure that what I was seeing was right, I took another piece of brass tube that was bigger than the 5/16 and pushed my 1/8 inch tube in and sort of touched it where it touched, and the connection was all over the place. So and the tubes were about the same quality and same age, both from K&S Metals, probably about 30 years old, those two pieces of brass. So a success, I think, in that respect. So I'm going to wind this video up here. What I'll do before the video ends is I'll put up some stills of the building actually lit once we get completely dark this evening. I'll take some photographs and I'll post those on the end of this video. So thanks for watching. Please subscribe, give me a like, and if you normally follow me, tell me what you think. If you think what I've done is rubbish, then say so, but if you like it, then give me a thumbs up. So thanks for watching, and I'll see you again very soon. Bye.